Hey my dear data friends, it's Nicola from Data Mozart. Long time no see. In this video I want to show you what should be in every Power BI professional's performance tuner toolbox. So we will talk about various external tools and some of the internal features within the Power BI desktop that you can leverage to optimize the performance of your Power BI solutions. Namely, we are going to talk about DAX Studio, Tabular Editor 2, Bravo for Power BI and Vertipec Analyzer. Stay tuned! So let's go and understand what's in the Performance Tuner toolbox. Let's start with a tool that is at your disposal right out of the box. We are talking about the Performance Analyzer tool within the Power BI desktop. This is an extremely helpful feature because it enables you to figure out how each of your report elements performs and where the potential issue is. Performance Analyzer captures and displays the duration in milliseconds necessary for rendering or refreshing all the visuals that are affected by users' interaction. Not just that, once the Performance Analyzer displays the timings, you can perform various additional actions. For example, you may want to sort the timings by different criteria or to export Performance Analyzer results. Performance Analyzer collects and displays the performance measurement information in real time, so each time you click on a visual, move a slicer, or interact in any other way, Performance Analyzer immediately displays the performance results in its panel. There are three different categories of tasks that Performance Analyzer considers. DAX query. If a DAX query was required, this is the time between the visual sending the query and for Analysis Services Engine to return the results. If you are using Direct Query Storage mode, then you will also see a time spent on the direct query, which is approximately equal to a DAX query total time, because your DAX query is just being translated to SQL and pushed to a data source. Visual display. Time required for the visual to draw on the screen, including time required to retrieve any web images or geocoding. Other. Time required by the visual for preparing queries, waiting for other visuals to complete, or performing other background processing. Fine, let's now move on outside of the Power BI desktop. And there is a wonderful world of external tools out there. There are many external tools around, literally dozens, but of course we will not examine each of them in this course. We want to focus specifically on two external tools that are immensely important for troubleshooting Power BI performance, and these are DAX Studio and Tabular Editor. Before we jump into explaining these two, just one important remark. External tools are developed and maintained by third-party contributors, not Microsoft itself. So external tools come with one serious limitation, or consideration, let's put it that way. They are not officially supported by Microsoft. However, that shouldn't minimize their importance, especially when we are talking about two mainstream and widely adopted tools, such as DAX Studio and Tabular Editor. Let's kick off with DAX Studio. This is an amazing tool created by Darren Gosbell and SQL BI guys, Marco and Alberto. I think it's fair to say, if you're dealing with performance troubleshooting and you're not using DAX Studio, well, good luck with that. DAX Studio offers a whole range of handy features that I could probably talk about them in the next hour or so, but let's try to focus on a few that you will be using most often when troubleshooting the report performance. I'm in the Power BI desktop and I have a simple table visual showing the total number of big orders for every single day. What is a big order? It is every single order with a sales amount greater than $500 US. So the business request is to analyze the number of big orders on a daily level. To calculate the number of distinct orders with an amount greater than 500, we'll use DAX formulas. The beauty of DAX is that you can achieve exactly the same result in multiple different ways. As you may assume, some of these ways are more optimal than others. To be able to measure the performance of the DAX measures, I'll use the free external tool DAX Studio. I can launch DAX Studio directly from the Power BI desktop. Of course, as a prerequisite, I need to have both tools installed on the same machine. I'll go to the External Tools tab on the top and select DAX Studio. Here we go. Let's first examine the main areas within the DAX Studio. On the top, you'll find a ribbon with various features, and most of the settings should be configured right there. On the left hand side, there is a model pane, where you can see all the tables, columns and formulas in your data model. The central area is where the real action happens. The main query window is reserved for writing DAX code, while just below this window you'll find an output area, where you can see different results related to your DAX query. Since I want to analyze the performance of the various DAX formulas, I'll turn on Query Plan and Server Timings options in the ribbon, and now I'm ready to write my DAX code. The idea is to use DAX to calculate the total number of big orders per date, as we had in Power BI Desktop. I've already prepared the calculation definition, so let me quickly explain the logic behind it. In this case, I want to perform a distinct count operation over my sales order number column and identify how many distinct orders we had. Next, as we want to keep only big orders, I'll introduce a filter function. Here, as a first argument, I'm providing the table that needs to be filtered, while the second argument instructs the engine that we need to keep only those rows where the sales amount is greater than 500. Sounds like a pretty common business request, so let's go and execute this statement by clicking Run in the top left corner. After more than 15 seconds, the query was successfully executed. 15 seconds, that's extremely slow. Imagine the report user waiting for 15 seconds to get results displayed. So what's wrong with this measure? Luckily, DAX Studio provides a set of tools to examine the performance of the DAX code. But first things first, I want to confirm that the results are correct. Don't forget, performance is important, but it's even more important to have valid figures in the report. Once I confirm that the numbers match the Power BI desktop, let's go to the Server Timings tab at the bottom. Here, you may find a whole range of useful information related to the DAX query. For example, you can see that the total time spent on this query was 15.5 seconds. You can also identify how much time was spent between the two Power BI engines. FE stands for Formula Engine, while SE is an abbreviation for the storage engine. You can also check the number of queries executed by the storage engine, and as you may notice, in this case, there were 1097 storage engine queries. I can scroll and click on each of these 1097 queries. Each of these queries is quite fast, somewhere around 15 milliseconds, but the problem is that there are more than 1000 of them, and therefore the whole execution took 15.5 seconds. You may also want to investigate why this happened by leveraging the Query Plan tab. There are two different query plans that the Formula Engine generates: Logical Query Plan and Physical Query Plan. This is a complex topic that needs a thorough understanding, but at this point just keep in mind that the Physical Query Plan doesn't necessarily need to follow the order of the Logical Query Plan. Let's now rewrite our DAX statement and try to improve the performance of the calculation. This time I'm using a very similar formula, again performing distinct count over the sales order number column, and again using a filter function. However, this time I'll introduce another function, all, that will remove all the active filters from my sales amount column. After all the active filters from the sales amount column had been removed, we will apply our require filter to keep only those rows where the sales amount is greater than 500. Essentially, very similar formula, but let's hit the clear cache and run in the top left corner and check the performance now. Results are the same, but this time we have one single storage engine query, and the total execution time is only 32 milliseconds. So instead of 15.5 seconds, we managed to reduce the execution time to 32 milliseconds. That's astonishing. Quick look at the query plan tells that complexity is gone. I'll now show you the third version of the DAX statement that should return exactly the same result. This time I'll be using a DAX keep filters function, which is different from the filter function, but should behave the same in this specific scenario. Same as in the previous case, we have one single storage engine query and again extremely fast execution. As you witnessed, we could have written the DAX query in multiple different ways to obtain exactly the same outcome. However, by rewriting our DAX calculation to include a filter on a single column instead of a whole table, we were able to improve the performance of the calculation immensely. And using DAX Studio and its powerful set of features helped us to quickly identify the problem and solve it by rewriting the DAX query. Tabular Editor is another very popular external tool developed by Daniel Oetiker. You should be aware that there are two versions of the product out there. Tabular Editor 2 is a free version and you can download it from the GitHub, either as a portable version or as a standalone installation. On the other hand, Tabular Editor 3 is a commercial version of the product and offers many advanced features. Although you can achieve most development and optimization tasks with a free version, there are certain features in Tabular Editor 3, such as DAX Debugger for example, that bring development experience to a whole new level. If you ask me, Tabular Editor 3 is a well worth investment. However, in this course, we'll be using a free version of Tabular Editor, as I want to be sure that all of you can leverage things that I'll show you in the next few minutes. First of all, Tabular Editor will significantly improve your Power BI development tasks. And when I say significantly, I mean really significantly. Either by defining measures in bulk, creating things like calculation groups or object level security, which are not available natively in Power BI Desktop. There are dozens of things that you will like in Tabular Editor. But now you're probably asking yourselves, optimizing the data model is such a broad topic. How can one single tool help me to apply all those recommendations that spread across thousands of books, videos, white papers and blog posts? Is Tabular Editor a kind of magic wand that can help me transform data model monster into beauty with just a few clicks? Of course not. Knowing general best practices for the data model optimization, which we already covered during this course, such as building a proper star schema, reducing the column cardinality, avoiding direct query whenever possible, still remains the key requirement. But Tabular Editor may help you quickly and easily identify potential violations of these best practices. Based on the insight gained, you can then decide if you want to apply these recommended practices or keep your original data modeling logic in place. Before I show you how to use Tabular Editor for this specific goal, I must admit that I wasn't completely honest with you. Tabular Editor alone will not save your data model from disaster. You have to use a Tabular Editor extension called Best Practice Analyzer. When dealing with problematic data models, Best Practice Analyzer will quickly become your best friend. This tool, or maybe it's better to say extension, was developed by Michael Kowalski from Microsoft. In a nutshell, the Best Practice Analyzer scans your tabular data model and warns you about all the issues and issues within the model. Some issues are just that, issues with double quotes. This means you can live with these issues without sacrificing the model performance. Best Practice Analyzer relies on rules. Each rule belongs to a certain category, such as DAX expressions, performance, formatting, and so on. Obviously, not all rules have the same importance for the model performance. That being said, from the model performance perspective, it doesn't matter if you capitalize the first letter of data model objects or hide foreign keys, but the implications may be significant if you haven't partitioned large tables, if your model contains many bidirectional or many-to-many relationships, or if you have many calculated columns and calculated tables in the model. Best Practice Analyzer is not something you get out of the box when you install Tabular Editor. You need to add it manually by running the script in the Advanced Editor window of the Tabular Editor. I'm in the Power BI desktop, and since I installed Tabular Editor 2 on the same machine, I can access it directly from the External Tools tab. Once I'm in, let me quickly walk you through the main areas and features of the Tabular Editor. On the left-hand side, you can see all the objects and properties of your data model, such as tables, relationships, roles, and so on. The central area is reserved for scripting. You may switch between the Expression Editor, where you can write your DAX statements, and the Advanced Scripting window, which enables you to write C# code to accomplish many repetitive tasks. In this demo, our focus will be a Best Practice Analyzer tool, which is an extension of Tabular Editor 2. Best Practice Analyzer combines a bunch of recommended practices for data modeling and scans your data model to check if these practices are in place. If you go to Tools on the top and select Best Practice Analyzer, you'll see a list of the objects that are not aligned with the best practices, organized per different topics, such as performance, DAX expressions, maintenance, naming conventions, and so on. Don't be scared, many of these rules will not have any impact on your model performance. However, they should give you a hint about the recommended way of doing things with your data model. You may also decide to manage this set of rules. Again, under Tools, select Manage BPA Rules, and a new dialog window will pop up, letting you choose between various options. You may want to disable certain rules that you don't consider relevant by unchecking the checkbox next to a rule name. You can also permanently delete specific rules. The best thing about Best Practice Analyzer is that once it identifies potential issues within your data model, it enables you to apply a quick fix for that issue. You can either choose to generate a fixed script and execute this script from the Advanced Editor window, or apply the fix immediately. Another very handy feature of the Best Practice Analyzer is the Edit Rule option. Once you select to edit a certain rule, you can see not only a rule expression, but also a rule description, and what's most important, a reference to an article that explains why sticking with that specific rule is considered a recommended practice. That's a very cool way to learn and understand various best practices related to enterprise data modeling. Finally, once you're done with all your adjustments, simply click on the Save Changes to Model button, and all the modifications you applied will be saved back to your Power BI data model. Bravo for Power BI is one of the newer external tools on the market. It's still not so popular and widely adopted as DAX Studio and Tabular Editor, but it contains some really useful features that may be helpful in performance tuning process. Since I've been using Bravo for Power BI for a while now, I've decided to include it in the course curriculum, as I'm pretty sure that it can be super helpful in the certain scenarios. First of all, Bravo for Power BI is a free tool, created by SQL BI guys Marco and Alberto. To a certain extent, it's very similar to Vertipaq Analyzer, so you can also see key metrics related to your data model size, also nicely visualized. But it goes one step further, and this step may be crucial in the process of data model size optimization. Remember when I told you that the initial step in the data model size optimization should be the removal of unnecessary columns? Bravo for Power BI will be your best friend in performing this task, as it will show you which columns within your data model are not being referenced. Based on that quick insight, you may decide what to do with these columns. But that's a great first step in data model size optimization workflow. Next, Bravo for Power BI comes with one unique feature that no other tool is offering, at least at this moment. And it is creating a date dimension table out of the box. Remember when I told you that there are 3 different ways to handle dates in your well-designed star schema data model? Leveraging the existing date dimension from the data warehouse, using mscript in Power Query, or using DAX within Power BI Desktop. Now let me introduce the 4th option. Bravo for Power BI enables you to quickly generate a date table based on any date field from your data model. Not just that, it also offers a possibility to generate a bunch of DAX time intelligence calculations that are common requirement in the majority of Power BI reports. I'll show you how to do this in the next video. Finally, you can use Bravo for Power BI to export the data, which could also be useful when troubleshooting the data model size and performance. Let me show you Bravo for Power BI in action. I'm in the Power BI desktop, and I'll quickly move to the External Tools tab and open Bravo directly from the ribbon. The initial screen provides you with a nice overview of your data model size. This reminds of the Vertipaq Analyzer, where you can also see the cardinality, size, and similar stuff. On the right hand side, the column size is visualized, but I want to emphasize another feature here. On the top, there is super useful information about the number of columns that are not referenced within the model. All the columns marked with yellow are not referenced. You can also see the same information for the specific table. The next useful feature is the DAX formatter. You know the saying, if it's not formatted, it's not DAX. This feature gives you the possibility to properly format your DAX code. And we are finally moving to the most important feature in Bravo for Power BI, at least in my humble opinion. Manage Dates enables you to create and customize a date table for your data model. So let's quickly do it. First, I can choose between different templates. Let's stick with the standard one. Next, I can select the day from which my week starts. By default it's Sunday, but you may want to switch it to Monday, for example. Now let's customize the interval. By default, Bravo will generate dates based on the automatic scan. You can also define your starting and ending year, and instead of the full scan, specify the column where Bravo will scan for the date range. I'll do exactly that and instruct Bravo to search within the order date column in the fact internet sales table. Here the date starts from January 1st, 2018, so that will be our starting date. Next, I'll move on to dates, where I can define the regional format and date table name. Holidays, that's another handy feature you can use if you wish. Obviously, not all countries are currently covered, but still, since I live in Austria, I'm happy to have an opportunity to create with a few clicks a fully functional table with public holidays in Austria. Last, but definitely not least, time intelligence. As I told you, you can leverage Bravo for Power BI for creating a bunch of common DAX time intelligence calculations. You can either do it for all the measures in your data model or choose a specific measure, which I'll do now. Let's select the total orders measure. I'll click on preview changes, and once I confirm that everything looks good, I'll press apply changes. Let's go back to our Power BI report, and as you may notice, here is our newly created date table. It contains all the necessary fields, including the hierarchy. Down below in the fact internet sales table, there is a new folder containing automatically generated measures. You see usual things such as month over month, previous quarter, year over year, running totals, and so on. Let's quickly use some of this in our report. I'll first create a relationship between the date table and order date column from fact internet sales table. As you see, our calendar hierarchy works like a charm. Let's also include year-to-date calculation for our measure. There you go, quick and easy. As you've seen, Bravo for Power BI offers some really cool features, and I'm sure it will immensely help in optimizing the workflow in Power BI development process. Let's conclude this external tools topic by examining Vertipaq Analyzer tool. Vertipaq Analyzer was developed by SQLBI.com folks, Marco Russo and Alberto Ferrari, and you can download it directly from their website. However, the much more popular use case of the tool is directly from the DAX Studio, since the VertiPack Analyzer is integrated into it. In a nutshell, VertiPack Analyzer collects the data from various dynamic management views in analysis services. Don't forget, Power BI stores the data in the instance of the analysis services. Now you're probably asking yourselves, what is a dynamic management view? That's a good question, so let's quickly answer it. Dynamic management views are queries that return information about model objects, various server operations, connections, active sessions, and so on. You can run dynamic management views on your own from different client tools, such as SQL Server Management Studio or Azure Data Studio. However, it would be a tedious task to write multiple queries and collect and analyze all the data returned by these queries. And that's exactly where VertiPack Analyzer becomes your best friend. VertiPack Analyzer collects the data from various analysis services dynamic management views and displays them in a more convenient, easy to understand way. Essentially, VertiPack Analyzer enables you a quick and convenient insight into the data model structures. This insight provides you with a more clear picture of what is happening behind the scenes. Depending on the findings, you may decide to perform various optimization techniques that will increase the overall performance of your Power BI solution. I'm in the Power BI desktop and I want to show you how to determine the cardinality level of the column in your data model. As you see, I've put a plain card visual showing the total number of distinct values in the date-time column. And there are almost 9 million distinct values in that column. To be able to analyze the column cardinality, but also many other metrics related to a data model, I'll use a tool called DAX Studio. It's a free tool which can be downloaded from daxstudio.org. Once you install DAX Studio on the same machine where your Power BI desktop is, you can access it directly from the Power BI desktop. Go to the External Tools ribbon on the top and select DAX Studio. You should already be familiar with the main user interface of the DAX Studio. One of the handy features is a VertiPack Analyzer tool that collects data from different dynamic management views and displays it in a more convenient form. I'll go to the Advanced tab on the top and click on View Metrics. This will show a whole range of metrics related to a data model, such as table cardinality, table size, and percentage of space that a specific table occupies in the whole model. If you click on this small arrow next to a table name, you can see all these numbers broken down on a column level. And here is our date-time column with a cardinality of almost 9 million that you've previously seen in Power BI Desktop. You can see that this column takes 454 megabytes of space, as all these values are displayed in bytes. VertiPack Analyzer gives you a convenient and structured way to measure different aspects of your data model and understand the column cardinality levels. Now let's go to Power Query Editor and change the column data type from date-time to date. This way we remove the time portion, and this should help to improve the cardinality of this column. Once Power BI reloads the data, you may see that instead of 8.8 million distinct values, we now have only 1356. Let's check again in VertiPack Analyzer what kind of improvements that brought to our data model. By reducing the column cardinality from 8.8 million to 1356, column size was reduced from 454 megabytes to only 8 megabytes, which is approximately 1.5% of its original size. That's all, folks. I hope you enjoyed this video. If that was the case, please consider subscribing to Data Mozart YouTube channel. Also, if you find this video useful, please click this like button down below. See you next time. Enjoy Power BI!